And now in this lecture we will find out the value of line segment X. In the drawing we have triangle ABC. We know that side AB is equal to side AE. We also know that angle BAC, this angle equals to 90 degrees, and angle BAD, this angle equals to theta. Angle EAC, this angle is also equal to theta. We also know that BD equals to 3 units, DE equals to 7 units, and we want to find out the value of line segment EC that is equal to X. Okay, so first of all, from point A, we draw perpendicular to BC. So this angle is equal to 90 degrees, and this angle is also equal to 90 degrees. We'll define the touching point of the perpendicular from point A and BC as M. We will define angle MAE. We will define angle DAE as alpha. Angle DAE equals to alpha according to definition. This angle equals to alpha, and we will calculate the area of triangle BAD, and we will divide the area of triangle BAD by the area of triangle ADE. So what is the area of triangle BAD? The area of triangle BAD equals to the base BD times the height to the base, that is AM. The height must create 90 degrees with the base, so you can see that line segment AM indeed creates 90 degrees with the base, so the height is AM. So the area of triangle BAD will be equal to the base BD times the height to the base, that is AM, over 2. Okay, so I'll write it down. The area of triangle BAD, here the squared brackets is the sign for the area. It means the area of triangle BAD will be equal to the base of the triangle, that is BD, times the height to the base, that is AM, over 2. And we divide the area of triangle BAD by the area of triangle BAE. So what is the area of triangle DAE? The area of triangle DAE will be equal to the base of the triangle, that is DE, times the height to the base, that is AM. You can see that AM creates 90 degrees with the base DE, therefore AM is the height to the base. AM is the height over 2. So we found out that the area of triangle DAE equals to DE, that is the base, times the height is that is AM over 2. Here we have 2 in the numerator and 2 in the denominator, so 2 will get cancelled, and what is left after we cancel 2 from this equation, what is left is, it is actually BD times AM over DE times AM. Here AM over AM is 1, so AM will get cancelled, and it is given us in the question that BD equals to 3 units, and here DE equals to 7 units. So in conclusion, we found out that the area of triangle BAD over the area of triangle DAE equals to 3 over 7. In the next step, we will calculate the area of triangle BAD in a different way. Here, the base of the triangle will be AB, so it will be equal to the base AB times the height to the base. The height to the base must create 90 degrees with the base, so from point D we will go perpendicular to the base. The height must create 90 degrees with the base, and here we will define the touching point of the perpendicular from point D to AB is point O, so DO creates 90 degrees with the base AB, therefore DO is the height to the base, so we'll define the height DO as edge 1. So actually the height to the base AB is edge 1, all divided by 2. And we divide it by the area of triangle DAE. And here we will calculate the area of triangle DAE in a different way. We take the base of the area as AE. So AE is the base of the triangle, and the height to the base must create 90 degrees with the base. From point D we will go perpendicular to AE, so this angle equals to 90 degrees, and this angle will be also equal to 90 degrees. We define the touching point of the perpendicular from point D to AE as K. So AK creates 90 degrees with the base AE, therefore AK is the height to the base. So we define, actually DK creates 90 degrees with the base AE, therefore DK is the height to the base, so we will define DK as H2. So the area of triangle ADE will be equal to the base of the triangle, that is AE, times the height to the base, that is H2 over 2. So it is AE times the height to the base, that is H2, over 2. Here we have 2 in the numerator and 2 in the denominator, so 2 will get cancelled. And what is left after we cancel 2 from this expression? What is left? It is actually AB times H1 over AE times H2. Here we know that according to what is given us in the question, AB is equal to AE, therefore AB over AE will be equal to 1, so AB over AE will get cancelled, and we left only with the expression that 3 over 7 equals to H1 over H2. So in the next step, we'll find out the values of H1 and H2, and we'll put them inside the equation here. So what is the value of H1? If we focus on triangle AOD, on the right triangle AOD, then in this right triangle AOD, we know that sinus theta equals to H1 over AD. Sinus theta is equal to H1 over AD. We'll multiply this equation by AD, and we will get that the value of H1 is equal to AD sinus theta. Okay, now we can substitute H1 by AD sinus theta. In the next step, we find out the value of H2. Okay, so here we'll focus on the right triangle ADK. In the right triangle ADK, this right triangle, sinus alpha will be equal to H2 over AD. I'll repeat again. In the right triangle ADK, sinus alpha equals to H2 over AD. So we multiply this equation by AD, and we get that H2 is equal to AD times sinus alpha. Now we will substitute H2 by AD sinus alpha. So in conclusion, we found out that according to equation number 1, 3 over 7 is equal to sinus theta over sinus alpha. But what is the value of alpha? You can see that angle BAC equals to theta plus alpha plus theta. So angle BAC equals to 2 theta plus alpha from one side, And from the other side, angle BAC equals to 90 degrees. Okay, angle BAC equals to 2 theta plus alpha from one side. From the other side, it equals to 90 degrees. So from this equation, 90 degrees equals to angle BAC equals to 2 theta plus alpha, we will conclude that 90 degrees equals to 2 theta plus alpha. Here we subtract 2 theta from this equation, and we get that the value of angle alpha equals to 90 degrees minus 2 theta. Now we can substitute alpha by 90 degrees minus 2 theta, so we'll do it now, and we will get that according to equation number 1, 3 over 7 equals to sinus theta over sinus 90 degrees minus 2 theta. And according to the trigonometric identity, that it said that sinus 90 degrees minus x equals to cosine x. We will get that the expression sinus 90 degrees minus 2 theta according to this trigonometric identity will be equal to cosine 2 theta so we will substitute sinus 90 degrees minus 2 theta in equation number 1 by cosine 2 theta, and we will get that according to equation number 1, 3 over 7 equals to sinus theta over sinus 90 degrees minus theta, and according to this trigonometric identity, sinus 90 degrees minus 2 theta equals to cosine 2 theta. So we substitute sinus 90 degrees minus 2 theta by cosine 2 theta. Actually, we have another trigonometric identity for the value of cosine 2 theta. According to this trigonometric identity, cosine 2 theta is equal to 1 minus 2 times sine square theta. So we will substitute cosine 2 theta in equation number 1 by 1 minus 2 sine square theta. We'll do it now, and we will get that according to equation number 1, 3 over 7 is equals to sine theta over cosine 2 theta, and according to this trigonometric identity, cosine 2 theta equals to 1 minus 2 times sine square theta. So we substitute cosine 2 theta in equation number 1 by 1 minus 2 sine square theta. In the next step, we will cross multiply equation number 1, and we will get that according to equation number 1, 3 times 1 minus 2 sine square theta equals to 7 times sine theta Here we'll open the brackets on this side of equation number 1 and we get that according to equation number 1, 3 times 1 is 3 and 3 times minus 2 sine square theta is equals to minus 6 times sine square theta, that equals to 7 times sinus theta. So we will add 6 sine square theta to this equation number 1 and we'll subtract 3 and we get a quadratic equation. It states that 6 times sinus square theta plus 7 times sine theta minus 3 equals to 0. So we got here a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. This is the general formula for a quadratic equation, and in this general formula, a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for, and we find out the value of x according to a special formula for x, that is actually x equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. Okay, in our specific equation, in our specific quadratic equation, the variable that we are looking for is sinus theta. So x equals to sinus theta. The coefficient a equals to 6. The coefficient b equals to 7. And the coefficient c equals to minus 3. Now we will put the data inside the equation for x and we will find out the value of sinus theta. Here x equals to sinus theta, so we get that sinus theta equals to minus b. B is 7, so minus b is minus 7, plus minus square root of b squared. B is 7, so b squared will be equal to 7 squared. 7 squared is 49. Minus 4 times a is 6 and c is minus 3. C is minus 3. Divided by 2a. A is 6, so it is 2 times 6. So we actually got here the question that states that sinus theta equals to minus 7 plus minus square root of 49 plus minus 4 times minus 6 is minus 24, and minus 24 times minus 3 is 72. Okay, all divided by 2 times 6 is 12. So, in conclusion, we found out that sinus theta equals to minus 7 plus minus 49 plus 72 is 121. So it is inside the root we have 121 divided by 12. So found out that sinus theta equals to minus 7 plus minus the square root of 121 is 11 divided by 12. So here we will have two solutions that are possible for sinus theta. The first solution for sinus theta is that sinus theta is equal to minus 7 minus 11 over 12. This is the first solution for sinus theta. And we have also the second solution for sinus theta. The second solution for sinus theta is that sinus theta equals to minus 7 plus 11 over 12 so here minus 7 minus 11 is minus 18 over 12. So we found out that sinus theta equals to minus 18 over 12 is minus 1.5. But actually the function sinus accepts values from that are equal or greater than minus 1 and that are equal or smaller to 1. Okay, so the range of the values that sinus theta accepts is from minus 1 to plus 1. And because of the fact that minus 1.5 is less than minus 1, therefore this value exceeds the values that the function sinus accepts. Therefore, that is to say, sinus theta can never accept the value of minus 1.5 because the minimum value that sinus theta can accept is minus 1. Therefore, this solution is an incorrect solution. We'll cancel this solution and we will left only with the solution that sinus theta equals to minus 7 plus 11 over 12. Minus 7 plus 11 is 4 over 12. Here we will divide both the numerator and the denominator of this side of the equation by 4 and we'll get that 4 over 4 is 1 and 12 over 4 is 3. So in conclusion, we found out that sinus theta is equal to 1 over 3. Sinus theta equals to 1 over 3. So actually triangle BAE is an isosceles triangle because of the fact that AB is equal to AE. AB equals to AE. It is given us the question that AB is equal to AE. Therefore, we can write down that triangle BAE is an isosceles triangle because of the fact that it is given us in the question that side AE is equal to side AB. Okay? Side AB is equal to side AE. So I will draw again the right triangle ABE. So this is the isosceles triangle ABE. The base of the isosceles triangle ABE is BE. So I write it down. BE is the base. And AM is the height to the base BE because of the fact that AM creates 90 degrees with the base BE. And we have rule number 1. According to rule number 1, the height to the base in an isosceles triangle bisect the base. I will read rule number 1 again. According to rule number 1, the height to the base in an isosceles triangle bisect the base. So here we have the height AM to the base BE bisect the base BE. That is to say, BM equals to ME according to rule number 1. And if we define BM as X, then from this equation X equals to BM equals to ME, we conclude that ME is also equals to X. So we actually know that ME equals to X and BM is also equals to X. From the drawing you can see that BE equals to BM plus ME. So from one side, BE equals to BM plus ME. Okay? But from the other side, you can see that BE is equals to BD plus DE. BE equals to BD plus DE. From the other side, but BD equals to 3 units and DE equals to 7 units. So in conclusion, BD plus DE equals to 10. So from the other side, BE equals to 10 units. So BD equals to BM plus ME. BM equals to X and ME equals also to X, so it is X plus X, that is 2X. So from one side, BE is equals to 2X. And from the other side, BE equals to 10. So from this equation, we will conclude that 10 equals to 2x. We divide this equation by 2 and we get that x equals to 5 units. So actually we found out that ME that equals to x equals to 5 units and BM that is also equals to x equals to 5 units. So we can write down that here BM equals to 5 units BM equals to 5 units and ME is also equal to 5 units. Okay? In the next step, we will prove that the right triangle, triangle ABM, can went to the right triangle, triangle AME. Okay? So here, we will focus on the right triangle, triangle ABM. and the right triangle AME. So why those two triangles can go into each other? First of all, we know that AB equals to AE. It is given us in the question that AB is equal to AE. It's given us in the question. We just right now found out that BM is equals to ME is equal to 5 units. And AM is the common side, it belongs to both triangles. So we learned out that AM equals to itself. AM equals to AM is a common side that belongs to both triangles. Actually, we proved that the right triangle ABM congruent to the right triangle AME. This is the sign of congruent. According to side rule. Okay, we actually proved that all the sides of the right triangle ABM converge to all sides of the right triangle AME. Therefore, those two triangles converge to each other according to side rule. And from the fact that those two triangles can go into each other, we will conclude that angle BAM, this angle, BAM is equal to angle MAE, this angle. I'll repeat again that we can conclude from the fact that those two triangles can go into each other that angle BAM is equal to angle MAE according to the rule that corresponding angles in congruent triangles are equal to each other. Those two triangles can go into each other, therefore the corresponding angles, angle BAM and angle MAE, will be equal to each other. So if we define angle MAE as y, then from this equation y equals to angle MAE equals to angle BAM, we will conclude that angle BAM equals to y. So angle BAM equals to y, and angle MAE is also equals to y. And what is the value of angle BAE? The value of angle BAE is equal to theta plus alpha. Theta plus alpha. I'll repeat again. The value of angle BAE is equal to theta plus alpha. But here, according to our definition, angle BAM is equal to Y, and angle MAE is also equal to Y. Because of the fact that we found out that those two angles are equal to each other, therefore we define each angle as Y. So those two angles are equal to Y. That is to say, angle BAE is equal to Y plus Y. Okay, angle BAE is equal to Y plus Y, that is actually 2Y from one side, but from the other side, we've already found out that angle BAE is equal to theta plus Y. Theta plus Y. So from this equation, we will conclude that theta plus Y equals to theta plus alpha, of course, angle BAE from one side equals to theta plus alpha, and from the other side it equals to 2Y. So from this equation, we conclude that theta plus alpha equals to 2Y. We divide this equation by 2, and we will get that angle Y equals to theta plus alpha over 2. So we actually found out that angle Y equals to theta plus alpha over 2. Here, angle Y equals to theta plus alpha over 2. So angle Y equals to theta plus alpha over 2, and they also angle Y equals to theta plus alpha over 2. Okay, so in the next step we will focus on the right triangle AME. So I will copy the right triangle AME in a new page, and we will analyze the triangle AME. Triangle AME. we already found out that ME equals to 5 units. Angle MAE is equal to theta plus alpha over 2. So this is the right triangle, triangle AME. We will define side AM as edge, that is to say AM equals to edge according to our definition. So what is the value of tangent theta plus alpha over 2? Tangent theta plus alpha over 2 will be equal to ME over AM. Okay, I'll repeat again. Tangent theta plus alpha over 2 equals to ME over AM. But we've already found out that ME equals to 5 units and AM is equal to edge according to our definition. So in conclusion, we found out that according to equation number 1, tangent theta plus alpha over 2 equals to 5 over h. Okay, according to equation number 1, tangent theta plus alpha over 2 equals to 5 over h. In the next step, we will focus on the right triangle, triangle AMC. So I will copy the right triangle in a new page and we will analyze the right triangle, triangle AMC. The right triangle, triangle AMC. According to our definition, AM equals to H. And what is the value of MC from the drawing? It is very easy to see that MC equals to ME plus EC again. MC equals to ME plus EC. That is to say, MC equals to ME, that is 5 units, plus EC, that is X. So in conclusion, we found out that MC equals to 5 plus X. So this is the right triangle, triangle AMC. What is the value of angle MAC? From the drawing, it is very easy to see that the value of angle MAC will be equal to theta plus alpha over 2 plus theta. So it equals to theta plus alpha over 2 plus theta. angle MAC equals to theta plus alpha over 2 plus theta. Okay, so here now we know that the sum of the angles in the right angle triangle AMC is equal to 180 degrees. So that is to say, angle CAM plus this angle that is 90 degrees plus angle ACM, in total they must be equal to 180 degrees. So I will write it down. According to the rule that the sum of the angles in any triangle is equal to 180 degrees, we will get that angle MAC, this angle, plus this angle that is 90 degrees, plus angle ACM, in total the sum of those four angles must be equal to 180 degrees. Here we subtract 90 degrees from this equation, and we get that angle MAC plus angle ACM equals to 180 degrees minus 90 degrees is 90 degrees. So here we'll subtract angle MAC from this equation, and we'll get that angle ACM, the angle that we are looking for, is equals to 90 degrees minus angle MAC. So actually angle ACM equals to 90 degrees minus angle MAC, but we have already found out that angle MAC, this angle, equals to theta plus alpha over 2 plus theta. So here we will open the brackets in this equation, and we will get that angle ACM is equal to 90 degrees minus angle theta plus alpha over 2 minus theta. But according to what is given us in the question, angle BAC equals to 90 degrees from one side, but from the other side angle BAC equals to theta plus alpha plus theta. That is to say, angle BAC equals to theta to 2 theta plus alpha. Okay, from one side angle BAC, this angle is equal to 90 degrees, but from the other side it equals to 2 theta plus alpha. From this equation we'll conclude that 90 degrees is equals to 2 theta plus alpha. That is to say, we can substitute 90 degrees in this equation by 2 theta plus alpha. So we'll do it now, and we will get that this is actually angle ACM equals to 90 degrees, and according to this equation, 90 degrees equals to 2 theta plus alpha minus theta plus alpha over 2 minus theta. So here we have found out that angle ACM is equals to 2 theta minus theta is theta minus theta, it is actually theta angle ACM equals to 2 theta minus theta is theta plus alpha minus theta plus alpha over 2. So angle ACM equals to theta plus alpha over 2 minus theta plus alpha over 2 equals to theta plus alpha over 2. Again, we found out that angle ACM equals to theta plus alpha over 2. So I will draw again the right triangle, triangle ACM, and we will put the value of angle ACM that is inside angle ACM, that is actually equals to theta plus alpha over 2. So So this is the right triangle, triangle AMC. We just right now found out that angle ACM equals to theta plus alpha over 2. So in the right triangle, triangle ACM, we know that tangents theta plus alpha over 2 will be equal to AM over MC. Okay, tangent theta plus alpha over 2 equals to AM over MC. But we've already found, according to our definition, AM equals to H. And we've already found out that MC equals to 5 plus X. So in conclusion, we can write down that according to equation number 2, tangent theta plus alpha over 2 is equal to H over 5 plus X. So this is equation number 2. that tangent theta plus alpha over 2 equals to h over 5 plus x. But we have already found out that according to equation number 1, tangent theta plus alpha over 2 is equal to 5 over h. In the next step, we create equation number 3, that is the combination of equation number 1 with equation number 2. So equation number 3 states that tangent theta plus alpha over 2 is equal to, according to equation number 2, is equals to h over 5 plus x, while according to equation number 1, tangent theta plus alpha over 2 equals to 5 over h. Okay? Again, according to equation number 3, tangent theta plus alpha over 2 equals to h over 5 plus x, that equals also to 5 over h. In the next step, we find out the value of theta plus alpha over 2. What is the value of theta plus alpha over 2? Usually theta plus alpha over 2 equals to theta, and we have already found out that alpha is equal to 90 degrees minus 2 theta. So we substitute alpha by 90 degrees minus 2 theta, all divided by 2. So 90 degrees over 2 is 45 degrees, and theta minus 2 theta is minus theta, all divided by 2. So it is, in conclusion, we found out that theta plus alpha over 2 is equal to 45 degrees minus theta over 2. We know that if alpha equals to beta, then tangent alpha will be equal to tangent beta. Therefore, according to what I said, tangents theta plus alpha over 2 will be equal to tangents 45 degrees minus theta over 2. Okay, here we will use the trigonometric identity that states that tangents x minus y is equal to tangents x minus tangents y over 1 plus tangents x times tangents y. Okay, we use this trigonometric identity that tangents x minus y equals to tangents x minus tangents y over 1 plus tangents x times tangents y in order to find out the value of tangents 45 degrees minus theta over 2. According to this trigonometric identity, the value of tangent 45 degrees minus theta over 2 will be equal to tangent 45 degrees minus tangent theta over 2 divided by 1 plus tangent 45 degrees times tangent theta over 2. Okay, so we know that tangent 45 degrees is equal to 1, so it is 1 minus tangent theta over 2 over 1 plus tangent theta over 2. So in conclusion, we actually found out that tangent theta plus alpha over 2 is equal to 1 minus tangent theta over 2 over 1 plus tangent theta over 2. Okay? So in order to find out the value of tangent theta plus alpha over 2, we have to find out the value of tangent theta over 2. We have a special trigonometric identity for tangent theta over 2, and according to this trigonometric identity, we'll get that the value of tangent theta over 2 is equal to 1 plus sinus theta over cosine theta. So, I'll repeat again. Tangent theta, according to the trigonometric identity, tangent theta equals tangent theta over 2 equals to 1 plus sinus theta over cosine theta. But we have already found out that sinus theta is equal to 1 over 3. What is the value of cosine theta? We have the trigonometric identity that states that sine square theta plus cosine square theta is equal to 1. Here we subtract sine square theta from this trigonometric identity, and we will get that cosine square theta is equal to 1 minus sine square theta. We'll take a root out of this equation, and we'll get that cosine theta equals to the square root of 1 minus sine square theta. But we already know that sine theta equals to 1 over 3. If sine theta equals to 1 over 3, then sine square theta will be equal to 1 over 3 squared, that is 1 over 9. So I write it down. So, and we will get that cosine theta is equal to the square root of 1 minus sine theta squared is 1 over 9. And it equals to the square root of 1 minus 1 over 9 is 8 over 9. 8 is 4 times 2. And the square root of 4 times 2, the square root of 4 is 2. So it is, in conclusion, the square root of 8 is 2 times square root of 2 over the square root of 9 is 3. So in conclusion, we found out that cosine theta is equal to 2 times square root of 2 over 3 and we have already found out that sine theta is equal to 1 over 3. Now we can substitute the sine theta and cosine theta in this trigonometric identity by the values that we found for them. We'll do it now and we will get that tangent theta over 2 will be equal to 1 plus sinus theta is 1 over 3 over cosine theta. And we already found out that cosine theta equals to 2 times square root 2 over 3. So here actually here we will multiply 1 by 3 and then we'll divide it by 3 in order to have a common factor with 1 over 3 and we'll get that 3 over 3 plus 1 over 2 times square root of 2 over 3. So actually the trigonometric identity states that tangent theta over 2 is equal to cosine theta over 1 plus sine theta this is the trigonometric identity. Now we substitute cosine theta by 2 times square root of 2 over 3 and we'll substitute sine theta by 1 over 3 and we'll get that tangents theta over 2 according to this trigonometric identity equals to cosine theta, that is actually 2 times square root of 2 over 3 over 1 plus sine theta, that is 1 over 3. So we actually found out that Tangent theta equals to 2 times square root of 2 over 3 over 1 plus 1 over 3. Here we will multiply 1 by 3 and then we divide it by 3 in order to have a common factor with 1 over 3. And we will get that tangent theta over 3 is equal to 2 times square root of 2 over 3 divided by 3 plus 1 over 3. Here we have 3 both in the numerator and in the denominator, so 3 will get cancelled. And 3 plus 1 is 4. So we found out the tangent theta over 2 equals to 2 times square root of 2 over 4. Actually, the trigonometric identity of tangent theta over 2 is equal to 1 over sine theta over cosine theta we'll substitute sine theta by 1 over 3 and we'll substitute cosine theta by 2 times square root of 2 over 3 and we'll get that the value of tangent theta over 2 is equal to 1 plus 1 over 3 over 2 times square root of 2 over 3. Here we'll multiply 1 by 3 and then we'll divide it by 3 and we'll get that tangent theta over 2 is equal to 3 plus 1 over 3 divided by 2 times square root of 2 over 3. Here we have 3 in the numerator and 3 in the denominator, so 3 will get cancelled and we will get that tangent theta over 2 equals to 3 plus 1 is 4 over 2 times square root of 2 and so actually the trigonometric identity of tangent theta over 2 is equals to sinus theta over 1 plus cosine theta. So tangent theta over 2 will be equal to sinus theta is 1 over 3 over 1 plus cosine theta, and we already found out that cosine theta is equal to 2 times square root of 2 over 3. And we get that tangent theta over 2 equals to 1 over 3 over 3 plus 2 times square root of 2 over 3. So we have 3 in the numerator and 3 in the denominator, so we'll cancel 3. And we get that tangent theta over 2 equals to 1 over 3 plus 2 times square root of 2 . So here we take this expression of 1 over 3 plus 2 times square root of 2, and we will multiply it by 3 minus 2 times square root of 2, and then we will divide it by 3 times 3 minus 2 times square root of 2. So in the numerator we have 3 minus 2 times square root of 2, and in the denominator we have very algebraic expression that is very similar to the algebraic identity that a plus b times a minus b equals to a squared minus b squared. Here a equals to 3, so a squared is 9 minus b squared minus 2 times square root of 2 squared is 8. So in conclusion, we found out that this expression equals to 3 minus 2 times square root of 2, and 9 minus 8 is 1. So if we divide the denominator by, if in the denominator we have 1, it doesn't change the value of 3 minus 2 over 2, because anything that you divide by 1, it will be still the same, it will have still the same value. So in conclusion, we found out that tangent theta over 2 equals to 3 minus 2 times square root of 2. Now we can put this value inside the equation that states that tangent theta plus alpha over 2 is equal to 1 plus tangent theta over 2 over, it is actually 1 minus tangent theta over 2 over 1 plus tangent theta over 2. So we put the value of tangent theta over 2 inside this equation. We found out that tangent theta over 2 equals to 3 minus 2 times square root of 2. So we get the tangent theta plus alpha over 2 is equal to 1 minus 3 minus 2 times square root of 2 over 1 plus 3 minus 2 times square root of 2 over 2 times square root of 2. We get that tangent theta plus alpha over 2 is equal to 1 minus 3 is minus 2, minus and minus is plus, so it will be plus 2 times square root of 2 over 1 plus 3 is 4, minus 2 times square root of 2. So we actually found out that tangent theta plus alpha over 2 is equal to 2 times square root of 2 minus 2 over 4 minus 2 times square root of 2. Here we will take 2 as a common factor from the numerator, and inside the brackets we will have square root of 2 minus 1, and from the denominator we will take a common factor of 2 times square root of 2, and inside the brackets we will have 2 because of the fact that 2 times 2 square root of 2 is 4. Actually, in the denominator we will have square root of 2 because of the fact that square root of 2 times square root of 2 is equal to 4, and so it is 4 square root of 2 minus 1. So here square root of 2 over square root of 2 is 1, 2 over 2 is also 1. So in conclusion, we found out that tangent theta over 2, or tangent theta plus alpha over 2 is equal to 1 over square root of 2, and according to equation number 3, we have already found out that tangent theta plus alpha over 2 is equal to h over 5 plus x, that equals to 5 over h. So this is equation number 3. And we just right now found out that tangent theta plus alpha over 2 equals to 1 over square root of 2. From this long equation, we create the equation that states that 5 over h equals to 1 over square root of 2. Here we will cross multiply this equation and we'll find out that 5 times square root of 2 equals to h. So h equals to 5 times square root of 2. In the next step, we'll create the second equation that states that h over 5 plus x equals to 1 over square root of 2. H over 5 plus x equals to 1 over square root of 2. We have already found out that h equals to 5 times square root of 2, so we'll substitute h in this equation by 5 times square root of 2. We'll do it now and we'll get that 5 times square root of 2 over 5 plus x is equals to 1 times square root of 2. Here we'll cross multiply this equation and we'll get that 5 times square root of 2 times square root of 2 equals to 5 plus x. Square root of 2 times square root of 2 is 2 and 2 times 5 is 10. We concluded and found out that 10 equals to 5 plus x. Here we'll subtract from this equation minus 5 and we'll get that x equals to 5 units. Actually, x that equals to CE or EC equals to 5 units. That is the answer to the question. In the next step, I will summarize the lecture. Actually, we wanted to find out the value of line segment EC that equals to x. And here we have triangle ABC. We know that AB is equal to AE. We also know that BD equals to 3 units, DE equals to 7 units. We also know that angle BAC, this angle is a right angle, it equals to 90 degrees. Angle BAD equals to theta. Angle EAC is also equal to theta. And we want to find out the value of line segment EC that equals to x. Okay, first of all we defined angle DAE as alpha, and from point A we do perpendicular to BC. So this angle equals to 90 degrees and this angle is equal to 90 degrees, and we define the touching point between the perpendicular from point A and BC as M. And then we found out the area of triangle BAD. We divide it by the area of triangle DAE. What is the area of triangle BAD? The area of triangle BAD equals to the base of the triangle that is BD times the height to the base that is edge 1. The height to the base is AM, Again, the base of triangle ABD is BD, the height to the base, it creates 90 degrees with the base, so the base is AM, because it creates 90 degrees with the base BD, so it is BD, that is the base times the height, that is AM over 2. So the area of triangle BAD equals to the base BD times the height AM over 2. What is the area of triangle DAE? The area of this triangle equals to the base of the triangle that is DE times the height to the base that is AM over 2. Again, the area of triangle DAE equals to the base DE times the height to the base that is AM over 2. Here, 2, we have 2 in the numerator and 2 in the denominator, so 2 will get cancelled. And we got here BD times AM over DA, DE times AM, so AM over AM is 1, so it will get cancelled. And we left only with BD over DE, but BD equals to 3 units. It is given as the question, and DE is also equals to 7, DE equals to 7 units. It is also given as the question. So in conclusion, we found out that the area of triangle BAD over the area of triangle DAE equals to 3 over 7. Then we calculated in another way the area of triangle ABD. Here, the area of triangle ABD can be calculated in another way. We take the base as AB. If the base is AB, then the height to the base must create 90 degrees with the base. So the height will be DO, that creates 90 degrees with the base. And DO is defined as edge 1. So the second way to find out the area of triangle ABD is to take AB as the base times the height to the base DO is edge 1 over 2. So in conclusion, the area of triangle ABD will be equal to AB, that is the base, times the height to the base, that is edge 1 over 2, over the area of triangle DAE. Here we calculate the area of triangle DAE in another way. We take AE as the base, and then the height to the base must create 90 degrees with the base. So here DK creates 90 degrees with the base AE. So dk, that is defined as h2, is the height. So in conclusion, the area of triangle ADE will be equal to the base AE times the height h2 over 2. Again, the area of triangle ADE will be equal to the base AE times the height, that is h2 over 2. Here we have 2 in the numerator and 2 in the denominator, so 2 will get cancelled, and we left with AB times h1 over AE times H2, but because of the fact that it is given as the question that AB equals to AE, AB over AE will be equal to 1, so AB over AE will get cancelled, and we left only with H1 over H2. Okay? So, we found out that 3 over 7 equals to H1 over H2. So we have to find out the value of H1 and H2. We focused on the right triangle, triangle AOD. In this right triangle, here sinus theta equals to H1 over AD. In the right triangle, triangle AOD, sinus theta equals to H1 over AD. We multiply this equation by AD and found out that H1 equals to AD times sinus theta. Here, H1 equals to AD sinus theta, then we found out the value of H2. What is the value of H2? Here we focused on the right triangle, triangle ADK. In the right triangle, triangle ADK, sinus alpha equals to H2 over AD. In the right triangle, triangle ADK, sinus alpha equals to H2 over AD. We multiply this equation by AD, and we found out that H2 equals to AD times sinus alpha. Okay, H2 equals to AD times sinus alpha. So here, H2 equals to AD times sinus alpha. So in conclusion, we found out that 3 over 7 equals to sinus theta over sinus alpha. We know that 90 degrees is equal to angle BAC, and from one side, but from the other side, the value of angle BAC is equal to 2 theta plus alpha. So from this equation we will conclude that 90 degrees equals to theta plus alpha. We will subtract 2 theta from this equation and we will find out that angle alpha equals to 90 degrees minus 2 theta. Therefore we can substitute angle alpha in this equation by 90 degrees minus 2 theta. We did it and we got that according to equation number 1, 3 over 7 equals to sinus theta over sinus 90 degrees minus 2 theta, that is actually angle alpha. Then we just multiply the equation number 1 and we got that, but before that we have the trigonometric identity. That states that sinus 90 degrees minus x equals to cosine x. So according to this trigonometric identity, we get that the value of sinus 90 degrees minus 2 theta equals to cosine 2 theta. Therefore, we can substitute sinus 90 degrees minus 2 theta in equation number 1 by cosine 2 theta. We did it, and we got that 3 over 7 equals to sinus theta, and we substituted sinus 90 degrees minus 2 theta by cosine 2 theta, and we got the equation that states 3 over 7 equals to sinus theta over cosine 2 theta. Then we have another trigonometric identity for cosine 2 theta. According to this trigonometric identity, cosine 2 theta equals to 1 minus 2 sine squared theta. According to this trigonometric identity, we can substitute cosine 2 theta in equation number 1 here by 1 minus 2 sine squared theta. We did it, and we got that according to equation number 1, 3 over 7 equals to sine theta over 1 minus 2 sine squared theta. We cross multiply the equation number 1, and we got that 3 times 1 minus 2 sine squared theta equals to 7 times sine theta. We open the brackets in this side of equation number 1, and we got that 3 times 1 is 3, and 3 times minus 2 sine squared theta equals to minus 6 times sine squared theta, that equals to 7 times sine theta. Here we added 6 sine squared theta, and we subtracted 3 from this equation number 1, and we got the quadratic equation that states that 6 sine squared theta plus 7 sine squared theta minus 3 equals to 0. The general formula for quadratic equation is ax squared plus bx plus c equals to 0. Here a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for, and we will find out the value of x according to the following formula, that x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. Here the variable that we are looking for in our specific quadratic equation is sinus theta, so x equals to sinus theta, the coefficient a equals to 6, the coefficient b equals to 7, and the coefficient c equals to 3. So here we got that, put the data inside the equation for x, and we found out the value of sinus theta. X equals to sinus theta, so sinus theta will be equal to minus b, b is 7, so minus b is minus 7, plus minus square root of b squared. B is 7, so b squared is 7 squared, 7 squared is 49, minus 4 times a is 6, times c is minus 3. So here, minus 4 times 6 is minus 24, and minus 24 times minus 3 times minus 3 is equals to 72. So in conclusion, we found out that sinus theta equals to minus 7 plus minus square root of 49 plus 72 over 12. 49 plus 72 is 121. So we got in conclusion that sinus theta equals to minus 7 plus minus square root of 121 over 12. The square root of 121 is 11, so we found out in conclusion that sinus theta equals to minus 7 plus minus 11 over 12. So here we will have two solutions that are possible for sinus theta. The first solution for sinus theta is that sinus theta equals to minus 7 minus 11 over 12. And the second solution for sinus theta is that sinus theta equals to minus 7 plus 11 over 12. In the first solution, minus 7 minus 11 is minus 18, and minus 18 over 12 is equal to minus 1.5. So we found out that according to this solution, sinus theta equals to minus 1.5. But because of the fact that sinus can receive only values, can accept only values that in the range of from minus 1 to plus 1, and minus 1.5 is less than minus 1, therefore it exceeds the range of the values that sinus theta can accept. That is to say, sinus theta can never be equal to minus 1.5 because of the fact that sinus theta can accept values only from minus 1 to plus 1. So this solution is incorrect solution. We cancel this solution and we left only with the solution that sinus theta equals to minus 7 plus 11 over 12. Minus 7 plus 11 is 4, so 4 over 12. Sinus theta equals to 4 over 12. We divided both the numerator and the denominator of this equation by 4. 4 over 4 is 1 and 12 over 4 is 3. So in conclusion, we found out that sinus theta equals to 1 over 3. Then we focused on triangle and on the isosceles triangle BAE. Why triangle BAE is an isosceles triangle? Because of the fact that it is given us in the question that AB is equals to AE. And the base in the isosceles triangle BAE is BE, and the height to the base is AM. Why? Because AM is perpendicular to the base BE. So AM is the height to the base BE. And we have rule number 1. According to rule number 1, the height to the base in an isosceles triangle bisect the base. So here the height AM to the base BE bisect the base BE. That is to say, BM is equal to ME according to rule number 1. BM is equal to ME according to rule number 1. And if we define BM as X, then from this equation we conclude that ME equals to X. So BM is equal to X and ME is also equal to X. And what is the value of BE? Here BE is equal to BM plus ME from one side. BE equals to BM plus ME from one side. That is to say, it equals to BM, that is X, plus ME, that is also X. So from one side, BE equals to X plus X, that is 2X. But from the other side, BE will be equal to BD plus DE. That is to say, it will be equal to BD, that is 4 units, plus DE, that is 7 units. That is to say, BE will be equal to 3 plus 7, that is actually 10 units. From the other side, BE equals to 10 units, and from one side, BE equals to 2X. So from this equation, we will get that 10 equals to 2x. We divided this equation by 2 and we got that x equals to 5. So x is equal to ME, so ME is also equal to 5. And S is also equal to BM, so BM will be also equal to 5. Okay, so we can write here that BM is equal to 5 units and ME is also equal to 5 units. Then we focus on the right triangle, triangle AME, so I copied the right triangle, triangle AME in the new page, and we analyze the right triangle, triangle AME. Actually, before this, we proved that those two triangles, triangle ABM and triangle AME, can go into each other. Why those two triangles can go into each other? Because of the fact that AB equals to AE. AB equals to AE according to what is given us in the question. We have already found out that BM equals to ME equals to 5 units, and AM is equals to itself. AM is a common side, so it equals to itself as a common side. So actually we found out that triangle ABM can go into triangle AME according to side rule. And from the fact that those two triangles can go into each other, we will conclude that angle BAM is equal to angle MAE. Angle BAM is equal to angle MAE. According to the rule that corresponding angles that can go into triangles are equal to each other. Those two triangles can go into each other, therefore the corresponding angles, that is to say angle BAM and angle MAE, will be equal to each other. So angle BAM equals to angle MAE, and if we define angle MAE as y, then angle BAM will be also equal to y. So angle BAM equals to y and angle MAE equals to y. And what is the value of angle BAE? From the drawing you can see that the value of angle BAE is equal to theta plus alpha from one side. Angle BAE is equal to theta plus alpha from one side, but from the other side angle BAE equals to y plus y. Okay, that is to say angle BAE equals to 2y. So from this equation we'll conclude that theta plus alpha equals to 2y. Theta plus alpha equals to 2y. We divided this equation by 2 and we got that the value of angle y is theta plus alpha over 2. So here actually this angle BAM is defined as y. Therefore this angle will be equal to theta plus alpha over 2. Angle MAE is also defined as y. So this angle MAE will be also equal to theta plus alpha over 2. Then I copied the right triangle MAE in a new page and analyzed the right triangle MAE. So this is the right triangle MAE or AME. According to our definition, AM equals to H. We have already found out that ME equals to 5 units. And we just right now found out that again MAE equals to theta plus alpha over 2. So here in the right triangle AME, we can write down that tangent theta plus alpha over 2 equals to ME over AM. Tangent theta plus alpha over 2 equals to ME over AM, but ME equals to 5 units, AM equals to H. So in conclusion, we found out that tangent theta plus alpha over 2 equals to H over 5 according to equation number 1. Then we focused on the right triangle MAC, so I copied triangle MAC in a new page and we analyzed triangle MAC. This is triangle MAC. According to our definition, AM equals to H. And what is the value of MC? it's very easy to see that MC equals to ME plus EC. That is to say, MC equals to ME, that is 5 units, plus EC, that is X. So in conclusion, we found out that MC equals to X plus 5. And what is the value of angle CAM? The value of angle CAM or MAC, it is very easy to see that the value of angle MAC is equal to theta plus alpha over 2 plus theta. Okay, the value of angle CAM equals to theta plus alpha over 2 plus theta. And then we found out the value of angle ACM according to the rule that the sum of the angles in any triangle is equal to 180 degrees. That is to say, angle MAC, this angle, plus 90 degrees, plus this angle, this is actually angle CAM. In total, the sum of those two angles must be equal to 180 degrees. So angle MAC plus, we subtract the 90 degrees from this equation, and we got that angle MAC plus angle ACM equals to 180 degrees minus 90 degrees is 90 degrees. So angle ACM, we subtracted angle CAM from this equation, and we found out that angle ACM equals to 90 degrees minus angle MAC. So angle ACM equals to 90 degrees, and we already found out that angle CAM equals to angle, we already found out that angle CAM equals to theta plus alpha over 2 plus theta. So in conclusion, we found out that angle ACM, this angle equals to 90 degrees minus theta plus alpha over 2 plus theta. So angle ACM equals to 90 degrees. We open the brackets, so it is 90 degrees minus theta plus alpha over 2, and we have here minus before the brackets, so the sign of plus will become minus. So it is actually 90 degrees minus theta plus alpha over 2 minus theta. Here we know that 2 theta plus alpha equals to angle BAC from one side, from the other side angle BAC equals to 90 degrees. So from this equation we will conclude that 90 degrees equals to 2 theta plus alpha. So we can substitute 90 degrees by 2 theta plus alpha. We did it, and we got that angle MCA equals to 90 degrees, that is 2 theta plus alpha, minus theta plus alpha over 2 minus theta. Okay, theta, 2 theta minus theta is theta. So we have here theta plus alpha minus theta plus alpha over 2. And theta plus alpha minus theta plus alpha over 2 equals to theta plus alpha over 2. So we found out that this angle ACM, equals to theta plus alpha over 2. So I copied the right triangle, triangle ACM in a new page. And we found out that this angle ACM equals to theta plus alpha over 2. According to our definition, AM equals to H, and we have already found out that CM equals to X plus 5. So in this right triangle, triangle ACM, sinus tangents theta plus alpha over 2 will be equal to AM over MC. Tangents theta plus alpha over 2 equals to AM over MC. But AM equals to H according to our definition, and CM equals to 5 plus X. So in conclusion, we found out that according to equation number 2, tangent theta plus alpha over 2 equals to H over 5 plus X. This is according to equation number 2, but according to equation number 1, we have already found out that tangent theta plus alpha over 2 equals to H over 5. From equation number 1 and equation number 2, we can create the equation number 3 that states that it's the combination of equation number 1 with equation number 2. And according to equation number 3, tangent theta plus alpha over 2 from one side, according to equation number 2, it equals to h over 5 plus x. But from the other side, according to equation number 1, tangent theta plus alpha over 2 equals to h over 5 over h. So in conclusion, according to equation number 3, tangent theta plus alpha over 2 equals to h over 5 plus x, that equals to 5 over h. Then we found out the value of the value of theta plus alpha over 2. What is the value of theta plus alpha over 2? Actually, theta plus alpha over 2 equals to theta, and alpha equals to 90 degrees minus theta. Alpha equals to 90 degrees minus 2 theta. So we substituted alpha by 90 degrees minus 2 theta. So theta plus alpha over 2 will be equal to theta plus 90 degrees minus 2 theta over 2. We open the brackets here. So here 90 degrees over 2 is 45 degrees, and theta minus theta minus 2 theta is minus theta. So in conclusion, we found out that theta plus alpha over 2 equals to 45 degrees minus theta over 2. Theta plus alpha over 2 equals to 45 degrees minus theta over 2. So if alpha equals to beta, then tangent alpha equals to tangent beta, therefore tangent theta plus alpha over 2 will be equal to tangent 45 degrees minus theta over 2. Then we have the trigonometric identity that states that tangent x minus y equals to tangent x minus tangent y over 1 plus tangent x times tangent y. So here, according to this trigonometric identity, we will get that the value of tangent 45 degrees minus theta over 2 will be equal to tangent 45 degrees minus tangent theta over 2 over 1 times tangent 45 degrees times tangent theta over 2. So here tangent 45 degrees is 1 minus tangent theta over 2 over 1 plus tangent 45 degrees, that is 1 times tangent theta over 2. So in conclusion, we found out that tangent theta plus alpha over 2 equals to 1 minus tangent theta over 2 over 1 plus tangent theta over 2. Okay, so the only thing that is left to find is to find out the value of tangent theta over 2, and then in this way we get the value of tangent theta plus alpha over 2. And here we have actually we have trigonometric identity for tangent theta over 2. The trigonometric identity states that tangent theta over 2 is equals to sinus theta over 1 plus cosine theta, and we have already found out that sinus theta equals to 1 over 3. What is the value of cosine theta? We have the trigonometric identity that states that sinus square theta plus cosine square theta equals to 1. We subtracted sinus square theta from this trigonometric identity, and we got that cosine square theta equals to 1 minus sine square theta. Here we took a root out of this trigonometric identity, and we got that cosine theta equals to the square root of 1 minus sine square theta. So cosine theta equals to 1 minus sine square theta. Sine theta equals to 1 over 3, so sine square theta will be equal to 1 over 9. So we put the value of sine theta inside this trigonometric identity. Sine square theta equals to 1 over 9, and 1 minus 1 over 9 equals to 8 over 9, and 8 is 4 times 2, and the square root of 4 times 2 is, the square root of 4 is 2, so in conclusion the square root of 4 times 2 is 2 times square root of 2, and the square root of 9 is 3. So in conclusion, we found out that cosine theta equals to 2 times root of 2 over 3, and we have already found out that sine theta equals to 1 over 3. So according to this, according to the trigonometric identity, that tangent theta over 2 equals to tangent theta over 2 equals to sinus theta over 1 over cosine theta, we will get that tangent theta over 2 equals to, the trigonometric identity states that tangent theta over 2 equals to sinus theta over 1 plus cosine theta. Okay? And so tangent theta over 2 equals to sinus theta, that is 1 over 3, over 1 plus cosine theta. We have already found out that cosine theta equals to 2 times square root of 2 over 3. So tangent theta plus alpha over 2 equals to 1 over 3 over 1 plus 2 times square root of 2 over 3. Here we multiplied 1 by 3 and then we divided by 3 in order to overcome the factor of this expression, and we found out that tangent theta over 2 equals to 1 over 3 plus 2 times square root of 2 over 3. Here we have 3 in the numerator and 3 in the denominator, so 3 will get cancelled, and in conclusion we found out that tangent theta over 2 equals to 1 over 3 plus 2 times square root of 2. Okay? Tangent theta over 2 equals to 1 over 3 plus 2 times square root of 2. And we took the expression, this expression, and we multiplied by 3 minus 2 times square root of 2, and then we divided by 3 minus 2 times square root of 2. So in the numerator we have 3 minus 2 times square root of 2. And in the denominator we have expression that is very similar to the algebraic identity that states that a plus b times a minus b equals to a squared minus b squared. Here a is equals to 3, so a squared is 3 squared, 3 squared is 9. b is 2 times square root of 2. So minus b squared will be equal to minus 2 times square root of 2 squared, that is actually 8. So in conclusion, in the denominator we have 9 minus 8, that is 1, and in the numerator we have 3 minus 2 times square root of 2, and 3 minus square root of 2 over 2 over 1 equals to 3 minus square root of 2 over 2. So in conclusion, we found out that tangent theta over 2 equals to 3 minus 2 times square root of 2. So now we can put the value that we found for tangent theta over 2 inside this equation. According to this equation, we found out that tangent theta plus alpha over 2 equals to 1 minus tangent theta over 2 over 1 plus tangent theta over 2. So tangent theta plus alpha over 2 equals to 1 minus, and tangent theta equals to 3 minus 2 times square root of 2 over 1 plus tangent theta over 2 that equals to 3 minus 2 times square root of 2. So here we open the brackets, and 1 minus 3 is minus 2, minus and minus is plus, so here we have plus 2 times square root of 2, 1 plus 3 is 4. So here in the denominator we have 4 minus 2 times square root of 2. So in conclusion, we found out that tangent theta plus alpha over 2 equals to 2 times square root of 2 minus 2 over 4 minus 2 times square root of 2. Here from the numerator we took 2 as a common factor, inside the brackets we have square root of 2 minus 1, and from the denominator we took 2 times square root of 2 as a common factor, and inside the brackets what is left is square root of 2. Why? Because 2 times square root of 2 times square root of 2 is 4. So here, and what is left from 2 times square root of 2, after we took from it what is left from minus 2 times square root of 2, after we took from it 2 times square root of 2 as a common factor, what is left, it is actually minus 1. So here we have 2 square root of 2 minus 1 over square root of 2 minus 1 is 1, so it will get cancelled, and 2 over 2 is also equals to 1, so it also will get cancelled. So in conclusion, we found out that tangent theta plus alpha over 2 equals to 1 over square root of 2. Okay? And we have, according to equation number 3, tangent theta plus alpha over 2 equals to edge over 5 plus x, that equals to edge over 5. And we just right now found out that tangent theta plus alpha over 2 equals to 1 over square root of 2. So here, from this long equation, we can derive that edge over 5 equals to 1 over square root of 2. We of course multiply this equation, and we found out that edge equals to 5 times square root of 2. Then from this equation number 3, we can derive that edge over 5 over x equals to 1 over square root of 2. Edge over 5 over x equals to 1 over square root of 2, because multiplied this equation. First of all, we put the value of edge inside this equation, inside edge. So we substitute that edge by 5 times square root of 2, and we found out that 5 times square root of 2 over 5 plus x equals to 1 over square root of 2. Because multiply this equation, and we got that 5 times square root of 2 times square root of 2 equals to 5 plus x. 5 times square root of 2 times square root of 2 is 2, and 2 times 5 is 10. So in conclusion, we got that 10 equals to 5 plus x. We subtracted 5 from this equation, and we found out that x equals to 5 units. So x that equals to CE equals to 5 units. So we found here that x that equals to EC is equal to 5 units. So the answer to the question that x that is equal to EC is equal to 5 units. Okay, thank you very much.